4.5 limits at infinity and horizontal asymptotes. We've already talked about horizontal asymptotes, but we'll focus on that again throughout this lesson. So the first example here, example 1, graph the functions, find the limit. So let's look at part A. We have the limit of 5 minus 2 over x squared as x approaches infinity. So first of all, we're going to try to graph the function (5 minus 2 over x squared). Okay, so first of all, let's find the vertical asymptote. So the vertical asymptote, we've been doing this for the last few sections. Hopefully you see that the vertical asymptote is going to be x equals 0. Okay, and for the horizontal asymptote, notice that the degree of the numerator is less than the degree of the denominator. So typically the horizontal asymptote would be y equals 0, but we have this 5 here. This 5 is actually being added to this. This is 5. You can think of it this way. Negative 2 over x squared plus 5. So that's going to shift the whole graph up 5 units, which it would shift the horizontal asymptote up 5 units as well. The vertical asymptote doesn't really shift anything, or it does shift it, but since it's vertical, you don't notice a change. Okay, so let's try to graph this. Let's try it again. Okay, so we've got our vertical asymptote right here, which is x equals 0. We have a horizontal asymptote, 1, 2, 3, 4, 5, at the line y equals 0. And we're going to use a table to figure out how to graph the rest of this. So let's start by picking an x coordinate, an x point, to the left of the vertical asymptote. So I'm going to start with negative 1. If I plug negative 1 into my function, I'm going to get 5 minus 2 all over negative 1 squared is 1. So basically it's 5 minus 2, which would be 3. So negative 1, 3 would be here, which means the shape of this graph is going to look like this. Now let's pick an x coordinate to the right of the vertical asymptote. Let's try 1. Okay, if I plug 1 in, I'm going to get the same thing. I'm going to get 3 again. So it's going to look like this. Okay, so now that I have the graph, now I can use this idea of one-sided limits. I can say, okay, the limit, and I'm going to, since we said that this is f of x, I'm just going to write f of x here. The limit of this function as x approaches, well, we're just looking at positive infinity. X approaches infinity. So notice here, as x is approaching infinity, this is going to go, oh, that shouldn't be 0, it should be 5. This is going towards 5. So we don't need to use one-sided limits here. This is going to be equal to 5. Let's look at part B. For this limit, I think it would be difficult to graph 3 over e to the x. So instead, I'm going to write this limit as the limit of 3 as x approaches infinity, divided by the limit of e to the x as x approaches infinity. Hopefully you can see how those are equivalent to each other. And then let's just graph each of these functions. So the numerator, if I graph that function, that's going to be the function f of x equals 3. So as x is approaching infinity, okay, as the x is approaching infinity, it's still equal to 3. So the numerator is going to stay 3. Let's try the denominator. So, first of all, we need to try to graph e to the x. So this is an exponential function. Okay, if you would plug in 0 for x, you're going to get 1. If you're going to plug in 1 for x, you would get e, which is 2.718. Okay, and then hopefully, if you recognize that this is an exponential function, it's going to look like this. Okay, as x goes to infinity, this function goes to infinity. So you're going to have 3 over infinity. Again, we cannot write our answer this way. It's bad notation. You'll lose points on the test if you write it that way. You have to interpret this and know what this actually means. So again, infinity is a concept of a number growing without bounds. So think of this as being 3 over 100, or 3 over 1,000, or 3 over 10,000, or 3 over 100,000. If you would put all of these fractions in your calculator and see what the decimal equivalent is, you would notice that the numbers are getting smaller and smaller and smaller and going towards 0. So this is really equal to 0.